Okay, I promised you guys in class that you'd be working on a project at the end of this unit, and that's what we're going to do. So we're not going to actually finish off topics 7 and 8 from this unit. They're just talking about energy sources, and you've done that a bunch of times in science in the past, and you're going to do it again in grade 9. So we're actually going to skip that because it's not super essential. This is the project that you're going to do. So it's a building project. You're going to build a solar oven. So this is posted on D2L. These are your instructions. We'll go over due dates and stuff like that at the end. This is an individual project. You can't work in teams because we're trying to keep the social distancing, and it's not fair if one person builds the entire project and the other one doesn't. So this is an individual project. You are going to design and build a solar oven. A solar oven is a device that uses radiant energy from the sun to increase the temperature of an object placed inside the oven. So it's kind of like an oven in your house, but that uses electricity. This one, you are using the heat or the thermal energy from the sun to heat up something inside of your oven. So these are things that you need to do. So the first step you're going to do is to research the science behind solar ovens. So how they work, why they work, and you're looking at the three main methods of thermal energy transfer, so radiation, conduction, and convection. You are going to design a solar oven using materials that you find in your house. So since we're all kind of stuck inside right now, you can use any material you want in your house, recycled materials, new materials. Please do not go out and buy anything for this project. Use things that you already find in your house. I'm not expecting you to spend any money on this project or to go out to any stores, because that's not really the best idea right now, to buy materials for this project. So use what you have. You are going to build a prototype of your solar oven. So that just means you're actually going to physically build your oven. A prototype just means that it can be modified as you go. So if you start to build it, you decide you want to change something, it's a working model, it's a prototype. So you can change whatever you want, whenever you want. And you are going to explain, either in writing or a video, how you designed your solar oven, and you're going to explain using scientific vocabulary the principles behind it. So how it uses those three methods of thermal energy transfer. If it uses all three, or maybe it only uses some of them, you need to also explain the science behind it. So what's happening with the physical particles that make up the matter inside of your oven. So these are your specifications. You need to have a working prototype. So I want you to actually build your solar oven. I know I'm not going to physically be able to test it, and normally we would in class, but that's okay. I want you to build it. It's something kind of more fun to do, something hands-on, and you should have lots of materials at home, lots of like recycled materials, like glue, tape, paper, whatever you want, cardboard boxes, cereal boxes, whatever. You probably have lots of materials at home. Your oven must be able to open so that you can actually put something small inside of it. So I recommend making it so that you could fit just a normal sized coffee cup inside. But just like any oven, you have to be able to open it to put something inside. So don't seal it off completely. Normally how we would test your solar ovens is at school. I would have a beaker of water, probably like 100 milliliters of water. We would take the initial temperature of the water before putting it into your oven. We'd leave our ovens in direct sunlight for that solar radiation, probably for an hour, maybe even 2 hours, depending on the day. I mean, there's still snow outside, so this probably wouldn't work as well. And then we take a final temperature reading afterwards. So if you want to test it yourself, that's awesome. If you have, like, if you want to do like a coffee cup full of water and you have a thermometer, you can test it yourself and give me your results. Another really fun way to test it, but again, I don't want you going out to the store. If you have these materials, or if someone's already going out to the grocery store, a really fun way to test your solar oven is to make s'mores. So you get the graham crackers, the chocolate, and the marshmallow. You put them inside your oven for an hour or two and see if the chocolate has melted and see if the marshmallow's kind of expanded a bit. It's not necessary for you to actually test it. I'm just going to be looking at your design, but I'm just giving you ideas for kind of fun ways if you do want to test it. Next, you need to have a written or oral explanation of scientific principles that have to do with your solar oven. So everyone's going to be submitting a template into D2L, and I'll show you how to do that. If you're doing a video, most of your explanation is going to be on your video. Okay, but I realize not everyone wants to take a video of themselves or their project. So I need to have also a written portion as well. So that needs to be submitted. And I need to actually see your model. So whether that's in a video, a photo that you take and then post it into your written explanation, or if you can't do any of those, you can always take, you can always hand draw a picture of your prototype, maybe from a couple different angles, and then put that into your written explanation. So some things to maybe think about that will help you make your design for your solar oven. So first one, what materials make good insulators, or what materials make good conductors? Or do you even need to think about insulators and conductors if we're looking at radiation? Does the material inside the oven that the sunlight strikes, so that the sun actually hits inside the oven, does that make a difference? Do you want to have maybe colors that absorb a lot of energy, or do you want to have colors that reflect a lot of energy, or any other objects that absorb or reflect energy? Something to think about. I just talked about color. So does the color of it could also be inside or outside of your oven. So does the color matter? You might even want to go take a look at the color inside your oven right now. That might give you some clues. Does the thickness of the walls of your oven make a difference? Should the oven have any kind of opening, or should it be kind of sealed off? So do you want to have like a little window to let light in? Or do you want to have it kind of propped open a little bit so that sunlight can enter? Or do you want to have it completely closed off to anything from the outside? Does the size of your oven matter? So does a big oven heat up faster than a smaller oven? Something to think about. And then this last question is a little bit more of a research kind of question. What is active solar heating versus passive solar heating? And there's a textbook, there's a page number in the textbook if you want to go read more about that. The textbook also can be found on D2L, the digital copy. Okay, so lots of things to think about. When you're doing research, you're going to see probably even more than that. Okay, so how am I going to be marking you? So this is your grading scheme. This is your rubric. There's 3 main categories. So the categories are on the left. So the first one is your solar oven design. And there's 5 categories I'm going to be marking you on. So you can get 5 out of 5, 4 out of 5, all the way down to 1 out of 5. The design of your solar oven has a weighting of ×2. So if you get 5 out of 5, that's actually 10 out of 10. If you get 4 out of 5, that's 8 out of 10. So just multiply those numbers by 2. The second category is your explanation. This is the most important part of this entire project, so it's weighted at 3 times. So this whole category is actually out of 15. So if you get 5, that's 15 out of 15. If you get 4, that's 12 out of 15. If you get 3, right, that's 9 out of 15. So that one's worth quite a bit. This part is worth the least amount, so it's showing off your skills and your amount of effort put into your project. So that's just times 1. So 5 out of 5, 4 out of 5. Straightforward. So let's go back up and talk about the design. So the design of your project. To get full marks, you need to meet the specifications listed above. You need to have an effective use of properties of thermal energy transfer. So radiation, conduction, convection, you need to, first of all, really understand those principles, but you also need to find a way to maximize them inside your oven. To get a 4 out of 5, so it meets all specifications, except, that's a typo, except 1, or properties of thermal energy transfer are well done, but could use improvements. So you're almost there, but I can tell that you're just missing some kind of key elements maybe. 3 out of 5 meets all specifications except 2, or properties of thermal energy transfer are partially utilized. So they're kind of included in your design, but could use improvements. Okay, so that's a 3 out of 5. That would still be a passing mark. 2 out of 5, at this point this is not a passing mark. So meets all specifications except for 2, or properties of thermal energy transfer are somewhat utilized, kind of, sort of, but it requires significant improvements or significant changes. So you need to add a lot in there. 1 out of 5, so that's the lowest mark you can get. Basically just means that you didn't build a solar oven at all. All right, next part is our explanation. So this is the most important part. This is where most of your marks are going to come from. So half of your project, your marks are coming from your explanation, the part that you're going to submit onto D2L or send me a video. So to get a 5 out of 5, your design is clearly articulated. So that just means you explain every single part of your design to me, the size, the color, the materials used, the thickness of the walls, everything. Scientific vocabulary is used. So words like radiation, conduction, convection, particles, expand, contract, all those kinds of things. Demonstrate an excellent understanding of the properties of heat transfer, of energy transfer. So you're showing me in your explanation that you really understand thermal energy transfer. To get a 4 out of 5, design is clearly articulated. So you're just telling me all the parts of your design, and you're pretty much hitting all parts of, or all aspects of your design. Scientific vocabulary is used, and you're demonstrating a proficient understanding of thermal energy properties. So you pretty much understand thermal energy transfer, but maybe you're just missing some kind of key parts of it. Maybe a little bit more detail is required in your explanation, something like that. To get a 3 out of 5, Oh, sorry, there's a typo in this one too. Design is mostly clearly articulated, so it's a little confusing for me to understand what you're trying to say. Scientific vocabulary is somewhat used, so maybe you're not using all the words that we learned in science. You're not hitting those like key buzzwords. And you demonstrate a satisfactory understanding of thermal energy transfer properties. And you're missing a lot of detail in your explanation. So I kind of understand what you're saying. You're kind of showing that you understand, but not really. Like you're missing a lot of key elements as to what's actually happening inside of your solar oven. Okay, those are all passing marks. 2 out of 5 means that that's a not a passing mark. So your design is not clearly articulated. After I read your explanation, I'm still left kind of confused. Scientific vocabulary is somewhat used. Again, you're not showing me that you really understand what the words mean. And you demonstrate a lack of understanding of thermal energy properties. So maybe you mixed up radiation and conduction. You mix those two things up, or like you're not on the ball about what's going on. Okay, and then to get a 1 out of 5, that means that no explanation was provided to me. The last step, or last category, skills and efforts. So to get a 5 out of 5, so full marks, obvious efforts of extensive research. So you've put in a lot of time and thought into your research, and you show it to me on your templates. You have clear evidence of time and effort put into your design and your explanation. So it looks like you spent a lot of time on this. Right? It should look like you spent a fair bit of time on it, and kind of like you really actually enjoyed what you were doing when you're building your models and doing your prototype modifications. Okay, to get a 4 out of 5, so obvious evidence of research. So you've done the research, but maybe you just needed a little bit more to kind of take you to the next step. You have clear evidence of time and effort put into your design and your prototype modifications, but maybe you just needed a little bit more, this is what it says at the bottom, a little bit more time and effort to really perfect your design. To get a 3 out of 5, so there is evidence of research done, but you would really benefit from having more research. You've put in kind of minimal time and effort put into your project. Again, you need to spend a lot more time into building your solar oven to really perfect it. And that, like, a lot more time. You kind of just put it together really fast. Okay, those are all passing marks. To get a 2 out of 5, minimal research is done, and it just looks like you just slapped some stuff together to make your solar oven. To get a 1 out of 5, you're missing your research, you've kind of skipped over steps, or you just don't really have a project to show me. All right, so that's your overall project. That's how I'm going to mark you. So now let's take a look at the templates. So this is going to be posted on D2L as well. Okay, so sign 7, project solar oven. Due date is Monday, April 6, 2020. So you have 1 full week to work on this. You need to put your name on there. And then here's just some instructions. So you're going to fill out the templates. If you've done a video, you need to preferably, if you can like upload it somewhere and then post your link on the spot right here, that would be great. So just so that it's all in one place. If you can't find a way to actually link to your video, you can just send your video directly to me. My email address is up here. Just caroline.sutra@learn.cssd.ab.ca. You can send your videos there. If you're doing a video, you can skip certain parts of this template because you're just going to do it orally instead of typing up your answers. All right, so the first part A, this is your research. So everybody needs to complete this part. Basically, you're going to have bullet point notes on research for maybe design materials, what works, what doesn't, design shape, things like that. Anything you want, anything you research that you think is important, put in here, just bullet point notes. And then in brackets after each note, just please post or paste the website where you found that information, just to kind of reference where you got it. So everyone's doing that part. Part B, your picture. So if you're doing a video, you can skip this part because obviously I'll see your prototype in your video. You can take photos of your prototype and insert them here. Maybe do a couple different angles, like maybe one with your oven open, one with it closed, one from the front, one from the side. If you can't figure out how to take a photo and post it here, you can also do a hand-drawn photo. You might just have to print off the sheet and then scan it at the end. So again, if you're doing a video, you can skip that part. Part C, this is where most of your marks are coming from. This is your explanation of your solar oven. If you're doing a video, this part will be in your video, so you can skip it on the template. If you're not doing a video though, this is where you really have to focus a lot of your time. So this is where you're going to use your scientific vocabulary and you're going to explain every part of your design, like why it is the color it is, why you use the materials that you used, every single material, why the walls are so thick, why your project is maybe big or small. Explain everything to me, and then you also have to explain the science behind it. So how does it help heat up the inside of your oven? Because that's the entire purpose of this, is to try to heat up the inside of your oven as much as you can within that 1 or 2 hours. Part D, prototype modifications. So I want you to kind of, so everyone, actually this part can be part of your video as well. If you're making a video, you can kind of show me on there. If you're not doing a video, you do need to write it down. So as you're building your solar oven, are you modifying any parts to make it better? So maybe you started off with a really big cardboard box. And as you're building it, you kind of change your mind and you decide, actually, I think a smaller box will be better. Explain that here. So you're going to, any changes that you're making as you're building and designing your solar oven, I want you to explain to me here. And then the very last part, I want everyone to do this. You can do this on your video or specifically on here. You're going to self-evaluate. So on a scale of 1 to 10, how much time and effort did you put into this project? So 1 means like I did not put a lot of project into this. I just kind of threw it together last minute. 10 means I put a ton of effort and time into this project and I'm really proud of it. So I kind of want to gauge how you think you did on this project. Okay, the last thing I want to show you is where you're going to submit your project. So when you pull open D2L, make sure that you go to Science 7 first. This is just a news page. To access the Dropbox, you're going to hit Assessment and then Dropbox. So you can see I made a Dropbox called Project Solar Oven. What you would do, mine will show up different than yours, but you'd hit that and then you'd be able to scroll down. There would be a little button that says, I think it just says add a file. and you can click that and upload your template there. All I need is that template from you. I don't need anything else, unless you want to also somehow upload your video there as well. If you're doing this on a Google Doc, you need to make sure that your D2L is linked to Google. So to do that, you go back to your news page. And actually, no, we need to go to the home of D2L. So in the top left, you're going to hit the home button. This is the page that shows up when you first enter D2L. And then on the right, you're going to scroll down until you see it talk about Google. So right there, so Google Apps. So it already has my username and my accounts in there. So that means that my D2L is logged in to my Google account. So I should be able to access anything from my Google Drive through D2L. If it says something like access or find account or something, like there's a button that you would push, you just have to log into your Google and then that automatically links it. So if you do your template on a Google Docs, you just have to make sure that this step is done first before you can put anything into the Dropbox. And then obviously if you have any questions, feel free to email me, or we'll have a couple Google Meets this week if you want to just pop in and ask some questions really quick. So have fun building your solar ovens. Again, don't go out and buy any materials. Just use what you have at home, and good luck.